Hi all. The last session we discussed about the importance of Laplace transform and its application. We are going to discuss the very basic concepts of Laplace transform. First we define Laplace transform and regions of convergence, that is ROC, because without mentioning ROC, the Laplace transform is never defined. If we are finding the Laplace transform of some function, then we must define ROC. That is, for all functions, Laplace transform does not exist. So we have to check whether the region of convergence is exist or not. Otherwise, we can't find Laplace transform for some functions. Since Laplace transform is not always exist for some functions, okay, that we will discuss. We have know the Laplace transform is defined for continuous time signals. That is continuous time signal. I am drawing some signals. This is a sinusoidal signal. Then I am drawing another signal. Then another signal. These all signals have one property. What is that property? All signals are continuous functions of time. This is our time axis. Again time axis. And this is representing the signal f of t. Usually continuous time signal is represented by small alphabet f or small letters. Using small letters. Alright. Now you look at these figures. All the signals is defined only for t greater than 0. This is our origin 0, 0, 0. For all these three signals that I randomly drawn, the signal is existing only for t greater than 0. And f of t in these three cases is equal to 0 for t less than 0. Okay. So I am first going to define the Laplace transform of a single-sided signal for the signal which existing only for t greater than or equal to 0. That is, the Laplace transform of the signal f of t, this is a continuous time signal, that is equal to integral 0 to infinity f of t into e raised to minus sd. The integration is with respect to dt. Okay. And this is denoted by capital letter f of s. So the signal is usually represented by small letter f and whose transform is represented by capital letter F. Okay, right. So this is the basic definition of Laplace transform of a single-sided signal. That means the signal existing for t greater than or equal to 0. Now, as I said, this is unilateral Laplace transform of the signal f of t, that is denoted by capital letter f of s. And as per the definition, the integration 0 to infinity f of t into e raised to minus sd dt. That is unilateral Laplace transform. If the limits of the integration is from minus infinity to plus infinity, then this becomes bilateral Laplace transform. Okay. Now, what is a region of convergence? Region of the convergence or ROC. ROC. That means region of convergence. That is a region in S-plane. S-plane is a complex plane where the function is defined or the function is exist. Now, what is S? We know that S is a complex variable that is represented by S is equal to sigma plus j omega, where sigma is the real part and omega is the imaginary part. So S is a complex variable. So we can represent that in a complex plane. This is our S plane. Okay, this real axis represents sigma and the imaginary axis represents omega. So this is our S plane. For S plane we have 4 quadrants. First, second, third and fourth. Or in short, we usually say the S-plane is divided into 2 parts. One is RHS of the S-plane and this portion is LHS of the S-plane. Where sigma greater than 0, that is this portion. For this entire, this is a 0. For this entire portion, sigma is greater than 0. That is our right hand S-plane. And for this portion, sigma is less than 0 for this entire plane. That is called left half side of the S-plane. What is the importance of this S? Okay, Now I am taking this term e raised to minus st. So the transformation is from the integration f of t is multiplied by e raised to minus st, and we are integrating with respect to this integral. Lower limit is 0 and upper limit is infinity. Okay. Now what is the relation between e and s? Let us check it. I can write e raised to minus st as e raised to s is equal to sigma plus j omega. So e raised to minus of sigma plus j omega of t. That is the e raised to minus st term. Now I am splitting this term into e raised to minus sigma t into e raised to minus j omega t. Okay, so I can write this as in this form. Now e raised to minus sigma t, this term is called attenuation term, and this is our phase term. Now what is actually e raised to minus j omega t? And we know that e raised to minus j omega t can be written as cos omega t plus j sin omega t. So this can be written in this form. Okay. Now what is actually omega? Omega is equal to the angular frequency in radian per second. That is equal to theta by t. So from this equation we can write theta is equal to omega into t. So this becomes cos theta plus j sin theta. Okay, that means this can be represented in Phasor form. Phasor having a magnitude is equal to 1 at an angle theta. So this is a polar representation of cos theta plus j sin theta. That is equal to 1 at an angle theta. 1 means magnitude. Magnitude is root of cos square theta plus sin square theta. That is equal to 1. And at an angle theta. Now suppose I have a sine wave. This is my sine wave. Sine wave, right. So suppose this is sine wave. At t is equal to 0, theta is equal to 0. So I can represent this phasor as a phasor of magnitude 1. This is a phasor of magnitude 1 and angle is equal to 0. When the time increases, this will move. Okay, at this angle, this becomes 90. This is a theta is equal to 90 degree. So that can be represented by a phasor of magnitude unity and angle is equal to 90. And theta is equal to 45 degree. So this is phasor having magnitude 1 and angle is equal to 45 degree. This is the angle theta is equal to 180 degree. That means a phasor having magnitude unity and angle, this angle is 180 degree. And again this goes on. When this becomes, this is 270 degree. So this is the angle 270 and magnitude 1. And at this point this becomes 360 degree and phasor magnitude 1. That is the same point at 1 at an angle 0. So this is a phasor rotating in anti-clockwise direction. So 1 at an angle theta is a phasor rotating in anti-clockwise direction having magnitude 1. This is for one cycle. Then for next cycle, this rotation again continues. Then for another cycle, this rotation again continues. So this will repeat. And this is our attenuation factor. So this is the significance of e raised to minus j omega t. So the attenuation is determined by this factor e raised to minus sigma t. So this factor e raised to minus sigma t will control the region of convergence. In determining the region of convergence, this portion e raised to minus j omega t have no role. The role is only for e raised to minus sigma t. E raised to minus sigma t means sigma is the real part of the variable s. So for finding the region of convergence, the variable s is equal to sigma plus j omega. The sigma have role and omega term doesn't have any role for determining the region of convergence. This omega t we can represent a phasor rotating in anti-clockwise direction in this manner. Okay, so usually we are representing region of convergence is sigma greater than some value, some a, or sigma less than a. Sigma means, what is sigma? Sigma is the real portion of S. So sigma, I can write sigma is equal to real portion of S. That's sigma. And omega is the imaginary portion of S. Okay. Now when this term becomes 0, e raised to j omega t becomes 0, then whatever may be the magnitude of this, that means 0 into whatever this magnitude, that becomes 0. Right. When this becomes infinity, then whatever may be this, that infinity into this value. Okay. So this sigma, that is a real part of the S variable or real part of the complex variable, will determine the region of convergence. This is a concept you are going to use to find the region of convergence, and it is very, very, very much important, this concept. I think this concept is clear. If you have any doubt, you can contact me through VAVUTTA'Ns edu, either by WhatsApp or by you can message if you want any clarity in this session. Okay, then we can go to find the Laplace transform of some elementary signals. We are going to find the Laplace transform of a unit step signal, and we want to discuss where is the region of convergence and what is the procedure we are using to find region of convergence. Okay, now unit step signal is a unilateral signal. I can draw a step signal as the step signal having magnitude is equal to 1, represented by u of t. This is a function of time, this is 0. So the value of t less than 0, the signal has 0 magnitude, and for t greater than 0, the signal have magnitude is equal to 1. Now what is the Laplace transform of this signal? That we already know, that is equal to 1 by s. And how we find the region of convergence? Now, as per the definition, the Laplace transform of the signal u of t is equal to integral 0 to infinity the signal u of t into e raised to minus st dt. Right. Now, this is equal to integral 0 to infinity. The u of t is equal to 1 for t greater than 0. So I can replace u of t by 1. That is 1 into e raised to minus st dt. Right. Now I am integrating this term. So this is equal to minus 1 by s e raised to minus st. The limit of integration is from 0 to infinity. Okay. Now minus 1 by s is taken outside. So this is equal to minus 1 by s into e raised to minus s. T is substituted by infinity into infinity minus e raised to minus s into 0. Right. Now, let us consider this term. This term is e raised to minus s. Minus s means minus of sigma plus j omega into 0. So, 0 into any term, that becomes 0. So, this is equal to e raised to minus 0, that is equal to 1. E raised to minus 0 is equal to 1. Okay. Now, let us check this term. That is e raised to, I am taking this terms to here. E raised to s is replaced by sigma plus j omega. Our time is infinity. This is into infinity. I am going to split this term as e raised to minus sigma into infinity into e raised to minus j omega into infinity. Now we know that e raised to minus j omega is a vector, unit vector that rotating in anti-clockwise direction. So the magnitude of this entire term is decided by this factor e raised to minus sigma into infinity. I am going to write e raised to minus sigma into infinity. Suppose the value of sigma is equal to, sigma is minus 1. Then what happens for this term? This term become e raised to minus of minus 1 into infinity. That is equal to e raised to infinity. We know that e raised to infinity is equal to infinity. Right, e raised is a value 2.73. So 2.73 raised to infinity means 2.73 multiplying infinite times, that value is equal to infinity. So we have a one term here, this is infinity into this term, that is infinity. Infinity into anything is equal to infinity. Infinity minus 1. So this factor does not exist if sigma is equal to minus 1. Right. Now, suppose sigma is equal to 1. That means sigma is a positive value. That is, sigma is greater than 0. Sigma is equal to 1 means sigma greater than 0. What happens to this value? This becomes e raised to minus 1 into infinity. That is equal to e raised to minus infinity. E raised to minus infinity can write as 1 by e raised to infinity. That is equal to 1 by e raised to infinity is infinity. 1 by infinity, that is equal to 0. So this term become 0 when sigma is greater than 0. When sigma is less than 0, this term become infinity and the Laplace transform does not exist if sigma is less than 0. So this Laplace transform is defined only when this term is equal to 0. This term becomes 0 when sigma is greater than 0. So this become minus 1 by s into 0 minus 1. That is equal to minus 1 by s into minus 1. That is equal to 1 by s. And this existing only when this condition is satisfied. That is, sigma is greater than 0. Sigma greater than 0 means real portion of s is greater than 0. Therefore, region of convergence is sigma greater than 0 or real part of s is greater than 0. So in S plane, I can mark, this is my S plane. This is sigma. This is j omega. This is a point, sigma is equal to 0. This is sigma 1, sigma 2, sigma 3, sigma 4. So any point here, any point we are taking here, sigma is greater than 0. So this entire strip is the region of convergence. This is the RHS of the S plane. So anywhere is in this region. So this strip. So the region of convergence is always a strip or in a portion of some strips that we will discuss in detail. So for sigma less than 0, then what happens? The Laplace transform is does not existing for this function. For this function, the Laplace transform is defined. That is equal to 1 by x. If and only if the region of convergence, that is sigma, is greater than 0. This is our ROC. I think it is clear. If any doubt, you can message. Now, what about u of minus t? We can write u of minus t is equal to 1 for t less than 0 is equal to 0 for t greater than 0. Right. This is a folded signal. This signal can be drawn as u of minus t. This is equal to 1 for t less than 0. The value of the signal is 1 for t less than 0. For t greater than 0, the value of signal is equal to 0. Then what is the Laplace transform of this signal? And where is the region of convergence? Let us check. So, as per the fundamental definition, we know that Laplace transform of u of minus t, that is equal to integral. So, the integration is from minus infinity to 0. From 0 to infinity, the value of the signal is equal to 0. So, minus infinity to 0, the value of the signal is 1 into e raised to minus st dt. So, this is the definition of Laplace transform. That is from minus infinity to 0. The signal has value. From 0 to infinity, the value of the signal is equal to 0. So, I am integrating this. This becomes minus 1 by s into e raised to minus st, and the limit of integration minus infinity to 0. So this is equal to minus 1 by s is taken outside. E raised to minus s into 0 minus e raised to minus s. S is replaced by sigma plus j omega. This into minus infinity. Okay, so e raised to minus s into 0 means that is equal to 1. So this becomes minus 1 by s into 1 minus this term. What's the value of this term? This term can you write as e raised to minus of minus, that becomes plus. So that becomes sigma plus j omega into infinity. So I am taking this, writing this term as e raised to sigma into infinity into e raised to j omega into infinity. And again this term is a phasor of unit magnitude rotating in anticlockwise direction. Okay, in infinite number of times. Then time is equal to infinity. The rotation is infinite number of times. Now, what's the value of this? I am writing that term here, e raised to sigma into infinity. If sigma is greater than 0, for example, I am putting sigma is equal to some 2. So this becomes e raised to 2 into infinity. 2 into infinity is again an infinity. That is equal to e raised to infinity. That is equal to infinity. So what happens? This become 1 minus, this term become infinity. This entire term become infinity. So 1 minus infinity to infinity, so that is not defined, does not exist, or not defined. So for sigma less than 0, what happened? For example, sigma is equal to minus 1. This become e raised to minus 1 into infinity. That is equal to e raised to minus infinity, or 1 by e raised to infinity. That is equal to e raised to infinity is equal to infinity. 1 by infinity is equal to 0. So this function is defined only when sigma is less than 0. Okay, so when sigma is less than 0, this entire term becomes 0. So this becomes minus 1 by s into 1 minus 0. That is equal to minus 1 by s. Okay, minus 1 by s. So the region of convergence is sigma less than 0 for the signal u of minus t. So this is our S-plane, sigma j omega, and signal is u of minus t. This is all, this portion all here, the value, every point is sigma is less than 0. The sigma 0, minus 1, minus 2, minus 3, all this portion sigma is less than 0. So this is our region ROC. So we can write Laplace transform of u of t is equal to 1 by s, and region of convergence, that is sigma greater than 0. Sigma means real portion of s greater than 0. Now Laplace transform of u of minus t, that is equal to minus 1 by s. So I can write Laplace transform of minus u of minus t, that is equal to 1 by s. This minus is taken into the LHS. So for Laplace transform of u of t, the answer is 1 by s. And for Laplace transform of minus of u of minus t, the answer is again same 1 by s. But region of convergence here is sigma less than 0, or real portion of s is less than 0. So for both this function, both signals are different signals. U of t, the Laplace transform is 1 by s. This is Laplace transform minus of u of minus t. The answer is 1 by s. Both answers are same, but region of convergence is different. So for defining the Laplace transform, we should mention the region of convergence. So region of convergence is that much important. So in the next class we will discuss some more problems, and we will discuss the concept of region of convergence in detail. Okay, bye. Thank you.